Hello guys, this is Sahil Kamboj and welcome to my YouTube channel Data Science Story. In the previous video, we have learned how we can evaluate a machine learning model using a mean squared error. And in this video, we are going to learn a very basic fundamental concept of a machine learning known as the bias-variance trade-off. So let's do it. So what is bias? So bias is basically the inability of a machine learning algorithm to capture the true relationship between predictors and response. Okay, so here you can easily see that the black line here on the left hand side of your screen is the true relationship between the x and y, and the three different models are used to replicate this true relationship between x and y. The first is a linear fit model that you can see here with the yellowish line, and then there is a quadratic model that is used to replicate this relationship, and it is represented by the blue line here. And then at last there is a spline, more flexible model than the quadratic, and it is represented by the green line here. So as we have learned that bias is the ability of or inability of a machine learning algorithm to capture the true relationship between the predictors and response. You can clearly see here the linear model here that is represented by this line has the high bias because it is not able to predict the relationship that is represented by this black line. But on the other side, there is then comes a quadratic model, and it is very much able to predict this black line relationship. Then comes the more flexible model that is represented by this green line. Okay, it follows the data point so much that it also doesn't able to capture the true relationship that is represented by our black line. Okay, so I hope I able to understand you guys what is bias. Then comes a variance. So variance is the difference in fit of an algorithm for test data and for trained data. The variance tells us how a particular algorithm that we have selected to predict the true relationship able to perform on a unseen data. So here we observe how an algorithm perform for a unseen data, that is also called a test data. So if an algorithm performs good for the unseen data, we can say that algorithm has low variance. But if it not able to perform as we expected, then we can say that it has. So now what we want to achieve here is that the ultimate goal of an algorithm and machine learning project is to find an ideal algorithm that has both low variance and the low bias. You can clearly see in the left graph that this quadratic equation ables to capture the true relationship that is represented by this black line, and it is the ideal algorithm for this problem set. Okay, and we successfully able to find this sweet spot. On the right hand side of your screen, there are three lines that red represent the test mean square error, and the blue represent the bias, and the orange represent the variance. So you can clearly see here that after this point of line, there is sharp increase in the test mean square error, and there is also sharp increase in its variance, but its bias is decreased as the flexibility of our model increases. So we don't want this situation where the bias is very low and the variance is high because it doesn't perform on the unseen data. We also don't want this situation where the variance is where the bias is very high, like in the case of linear fit in this case, and the variance is low. This is also not desirable position for us. We want this position where there is low variance and the low bias. And now let's see how we can find that sweet spot. There are basically three methods that are used for this. The first is regularization, the second is boosting, and the third is bagging. And for the sake of this video, I'm not going to elaborate on these three methods or concepts. We will see in the later videos. So this is all that I have for this video. Thank you very much, guys. If you have any kind of doubt about this, please comment in the comment box, and stay tuned to my channel, and please subscribe to my channel Data Science Story. Thank you very much.